Hi guys, this is Rahul from Finance Excel, and today we'll be making a simple linear regression model, right? And my dependent variable would be SBI, my independent variable would be Bank Nifty, right? And we will be checking that how much variation in the prices of SBI is explained by Bank Nifty, right? So let us start, right? The purpose is to make a linear regression model. So let us start. First, we plot the prices of Bank Nifty and SBI on a scatter plot. Okay, so let me select the data. Let me delete this. So my independent variable is Bank Nifty and my dependent variable is SBI, right? We are checking that how much of the variation in the prices of SBI is explained by Bank Nifty. So Bank Nifty versus SBI. Right, so let us start with this dual Bank Nifty versus SBI. So we have to first calculate the line of best fit. Right, let me format the plot area here, format the axis here. So once I format the axis, you will be able to appreciate the linear relationship between Nifty and SBI. So you can see that there is this beautiful relationship. We can draw a very sweet and very crisp straight line along these points, right? I can easily fit a very simple straight line here, right? So we have a very good and nice linear relationship here. Okay. Right. So first we have for calculating the line of best fit, right? So before that, what is the line of best fit? Line of best fit is that line which minimizes the sum of square deviations between the predicted y and the actual y, right? And how do we draw the line of best fit, right? For drawing the line of best fit, first we have to calculate the slope of the line of best fit. How do we do that? Slope of the line of best fit is covariance, right, between s and y, x and y. So this is my y, this is my x, and I have my covariance, right? Next, I calculate the variance of Bank Nifty or variance of x, right? This is my variance of x. Now slope is equal to slope or is equal to covariance by variance, right? Now I have to calculate the mean of y. To calculate the intercept, I have to calculate the mean of SBI or y. Mean of SBI is what? Average of the actual values of actual prices of SBI. I've good here. I've calculated the mean of y, and then I'll calculate the mean of Bank Nifty, right? Which is x, right? Which is average. I've calculated the mean of Bank Nifty. Now I will calculate the intercept of the line of best fit. Slope of line of. Okay. So how do we do that? Y bar minus slope of line of best fit into mean of bank. So my slope is minus 156.11. Right guys, now we calculate the predicted y. Predicted y is denoted by y hat. So let me do that here. Y insert symbol, at, insert, close. Okay, this is my y hat, which is my predicted y. I calculate the predicted y with my model, minus 156.11 plus slope of the line of best fit into actual x. Let me log this, okay, and let me bring it back to 2 digits. Okay. So this is my predicted y, right? Now guys, on this particular scatter plot, I plot the line of best fit, right? So line of best fit. X values, my bank nifty, y value is predicted y, right? So you can see all these red spots, right? These are not pimples, these are the line of best fit. So let me draw a line, right, that superimposes. I'm drawing these points, drawing this line, right, to give you a better picture. Okay, so let me make the color red, right, and okay, so this red line is my, let me make it a bit thinner, right? Okay guys, so this is my line of best fit, right? Okay, so my model, what is my model now? My model is that y equals minus 156.1113 plus 0.013917 x, right? This is my model of my line of best fit. Again, the line of best fit minimizes SSE, right? What is SSE? Sum of square deviations between the predicted y and the actual y, right? Now I calculate the error terms, right? What is error term? Error term is nothing but predicted y minus y actual minus y predicted, right? Y actual minus y predicted. So let me copy this. Okay. Y actual minus y predicted. So this is my error term. Y actual minus y predicted. Now I square the error term. Error square is nothing but SSE, right? Again, we don't want so many decimal places. Don't want all this. Okay. So, guys, first remember that, see, the sum of residuals, right? The sum of residuals, if your line is your line of best fit, right? The sum of residuals will always equal 0, right? The negative deviations would cancel out the positive deviations, right? So my sum of errors would be 0. Guys, we can see this sum of errors equals 0, right? And okay, let me sum up the residuals. Okay, so the sum of squared residuals is 1041.05, right? So my SSE is 1041.05. Let me calculate SSE 1041. Okay, so this has come here. Let me bring it. Then guys, what is SSR? SSR is the variation, right? The variation that is explained by my regression model, right? So let me give you an idea of what SSR and SSE is. For giving you that idea, I have to calculate, or I have to plot the mean of y on my scatter plot. Mean of y. Mean of y is what? 277.29, right? So this is my mean of y. Let me plot this. I don't want it in 4 decimal places. I just want it in 2 decimal places. Okay, right. So let me plot this on my scatter plot here. Add mean of y. X values will have the actual x, right? And on the y axis, you will have the mean of y. Okay, guys, then you can see these gray dots on my scatter plot. I'll just superimpose a line over this. Okay. Guys, this is the mean of y. Now look what my chart is looking like, what my scatter plot is looking like. So this is my, guys, this is my, there is some problem. Let me see. This is my y bar or mean of y, right? All points along the line of best fit are y hat, and this blue dot here is the actual y, right? This is y actual, right? Total variation is this. Total variation is denoted by SST, right? The total variation is the difference between actual y and mean of y. And the difference between, right, SST is denoted by y minus y bar whole square, right? Guys, out of this variation between the actual y and the mean of y, this much variation is explained by my regression model or my independent variable, and this is known as SSR, right? This is known as SSR. Let me zoom the gaze. Okay, this is known as SSR. SSR is y hat minus y bar whole square, right? So this is the total variation from this blue dot to this mean of y, right? And it is given by y minus y bar whole square. Out of this total variation, this much variation is explained by my regression model, right? And this much variation is not explained by my regression model, and this is known as SSE. The goal of the line of best fit is to minimize this SSE, and SSE is given by y actual minus y hat whole square, right? So the goal is to minimize this SSE, right? So guys, again, this is the total variation between actual y and mean of y, which is given by SST. Out of this total variation, this much variation is explained by my regression model, which is given by y hat minus y bar whole square, and this minuscule variation is not explained by my regression model, which is SSE, which is given by y minus y actual minus y bar whole square, right? Okay, so once we are done with this, right, so let me zoom in now, right? Let me calculate the SSR. So my PC battery has gone down. Just a second. So SSR is what? Y minus Y hat minus. me charge guys, just a second. Let me start. Okay, let me charge it. Okay, so SSR is what? Y hat. Okay, so Y hat is insert symbol Y hat. Okay, insert close minus Y bar insert symbol. Okay, close. This is my SSR, right? SSR. Again, SSR can be is the difference between predicted Y and mean of Y. Right? Predicted Y minus mean of. I calculate the SSR. Predicted Y is this minus mean of Y is this. Right? Sorry. SSR predicted Y minus mean of Y whole square. Right? We square this up. Right? So predicted Y minus mean of Y whole square. Okay. This must be in a lot of decimal places. Right? This is my SSR. Right? Me reduce the zoom. Okay. This is my SSR. Now I sum up my SSR. So 69797.41 is the sum of SSR. Okay guys, so let us note this down. 1041.05 is SSE, we've already noted that, and 6797.41 is SSR. This is SSR. 6797 point how much? 411. Okay, so SSE is my unexplained variation and SSR is my explained variation. Right? So I'll just write down the definition of SSE, right? Variation in the total, variation in the dependent variable that is not explained by the independent variable or not explained by my regression model. And SSR is variation that is explained by variation in the dependent variable that is explained by the independent variable. So yes, this is SSR, this is SST. Now guys, this is SEC, this is SSR. Now we will calculate SST guys. Naturally SST is equal to SSE plus SSR, right? So is 7838.461, right? So we can calculate this as in this way also. total variation is what? Y minus Y hat, Y bar, right? Y minus Y bar whole square. Y minus Y bar whole square. This is my SST or my total variation. So my actual Y is this, my actual Y is this, my mean of Y is this. Okay, we square this. Again, it's in a huge decimal place. We don't want so many decimal places, right? I square this, drag and drop. 7838.463, 7838 point. See, this one is because of this. You can see this third decimal is not tallying because of some rounding off error, but we can conclude that SSE plus SSR is equal to SST, right? We've already done that. We added SSE and SSR here to get the SST, and here we actually calculated the SST by squaring the deviations between the actual Y and the mean of Y, right? Right, guys. So we've calculated SSE, we've calculated SSR, we have calculated SSE, everything we have calculated, right? Now, guys, we calculate something called R square. R square is also known as the coefficient of determination. R square is SSR by SST, right? What is the interpretation of R square? See, we can see that R square is 86.71. So the interpretation here is that 86.71% of the total variation in the dependent variable, that is SBI, is explained by the independent variable, that is bank nifty. And guys, for simple linear regression, R square is also can also be calculating by squaring the correlation between the two variables, right? So what is the correlation? Let me calculate the correlation between the two variables. Correl between this, comma, first I calculate the correl. What do you have? 0.93127. Let me guys just all of this that is written. Let me delete this. I hope all of this was clear with you. Okay. Okay guys, so the correlation is 0.9312287. If I square correlation, right? Correlation square, right? If I square this up, I will get R square or coefficient of determination, guys. We can see that both these figures are the same. Guys, please remember, right? R square will always be a value between, will always be a value within 0 and 1, right? And higher the R square, right? Better the fit of the model, right? Or we can say that higher the R square, right? We can say that higher the R square, the greater the variation in the dependent variable that is explained by the independent variable, right? So we can say higher the R square, better the fit of the model, better our model is in explaining the variation in the dependent variable, right? Guys, one thing more, right? If R square is equal to 1, right, this means that SSE equals 0 and SSR is equal to SST, or 100% of the variation in the dependent variable, 100% of the variation in the dependent variable is explained by the independent. Okay guys, so R square is for simple linear regression, R square is nothing but correlation square, right? Or it can also be calculated as SSR by SST. Higher the R square, better the fit of our model, lower the R square, right? Poor the explanatory power of our model, right? So a higher R square is telling me that, right, the independent variable is explaining the majority of the variation in the dependent variable, right? A higher R square is telling me that the majority of the total variation is being explained by the independent variable, right? The majority of the total variation is being explained by the independent variable, right guys? So I hope that you find this linear regression model useful. Okay, so bye bye guys.